Hi, I am Dr. My other name. I thought I should explain you something, the concepts in chapter 4, so it will help you to understand the concepts in chapter 4. So we start the chapter 4 with solutions. Um, we already learned solution has two parts, solvent and a solute. Solvent is the majority of the component while solute is the minority. And then the solutions we classify into three types: electrolytes, strong electrolytes, weak and non-strong electrolytes, anything completely dissociate in water. Example, ionic compounds, all strong acids, they're strong electrolyte, they readily dissociate in water and they conduct electricity. Non-electrolyte, they will not dissociate in water, all molecular or covalent compounds. So if you think of compare the conducting electricity in strong electrolyte, weak and non-strong electrolyte readily conduct electricity. That's what you see. This light bulb glows, and then this is non-electrolyte. They not conduct electricity. Um, but if the pure water does not conduct electricity because pure water is a molecular compound. So that is the in that section I can ask identify whether it's an electrolyte, non-electrolyte, weak electrolyte. So this table is important. All ionic compounds are strong electrolytes. All the strong acids are strong electrolytes. Weak acids and then weak bases are the ionic compound. All ionic compounds are strong, but weak electrolytes they are weak acids and weak bases. Non-electrolytes, substances that do not conduct electricity, are the other compounds that include all the molecular compounds. Like water, you take ethanol, think about the molecular compound, hydrogen peroxide, they are all molecular compounds. Combining with two non-metals do not conduct electricity. And with then we move to the next important topic, solubility. Solubility rules. You guys are lucky. Um, so I mean, you can have the solubility rules. You can look at it when you answer the homework and everything. So the solubility rules. Why we need to learn about the solubility rules? So you see, we use so many compounds in the laboratory. Um, So some ionic compounds they're completely soluble in water. You see they're dissolving, but some they do not. So how do you predict whether a compound is soluble in water or not? It's basically depend on the solubility rules. Solubility rules. I don't look at this chart. I know whether the compound is soluble or not because I use this simple trick, which is any compound in group 1. Remember the periodic table, group 1? Think about now I am thinking periodic table, which is um, sodium, potassium, lithium, sodium, potassium, rubidium, cesium, group 1. If your compound has group 1 metal, so what is a compound? Two or more elements: potassium chloride, lithium chloride, potassium sulfate, anything with group 1 completely soluble. And then those cations we call always soluble cations. Anions, what is this anion? If you remember, nitrate. This is acetate. If your compound has nitrate or acetate, compound for sure soluble. And then you see, generally we call, what are these? Chloride, bromide, iodide. There's a special name for this. Halides. We said, okay, these compounds generally soluble, except there are some exceptions: silver, mercury, lead. And then sulfates also generally soluble, except these group two metals: strontium, barium, and then mercury and lead. So usually, if you have any group 1 element, nitrate, acetate, for sure the compound is soluble. Example, I'm asking a question. Predict the solubility of magnesium nitrate. Soluble or insoluble? Soluble. Why? Because your compound has nitrate. Anytime, whenever your compound has nitrate, compound is for sure soluble. At the same time, I can ask some soluble cations, group 1. So these are like we call generally soluble. And then when you look at the insoluble compounds, um, you look at the sulfide, and then carbonates, phosphate, hydroxide, they are generally insoluble, except uh, alkali metals and ammonia. Another metal cation that always soluble is ammonia. So these are the solubility rules. In the exam, you can have this in front of you and answer the questions, but if you think about the long run, I would you look at that pattern. I'll keep in mind because now I don't want to look at this table. I know, so it's important you know the pattern. Always group 1 soluble, nitrate, acetate, or ammonium. It's for sure soluble. Okay, so that's the solubility rule. So example, you have an activity. I'm asking lead acetate is soluble or insoluble. I can immediately say soluble. Why? Acetate. Acetate is soluble anion. Tin sulfate, soluble. Why? Because you go up, look at the sulfate. Sulfate compound, all compounds soluble except strontium, barium, mercury, lead. That means strontium sulfate, barium sulfate, mercury sulfate, lead sulfate are only insoluble compounds. Anything else with sulfate is soluble. Ammonium sulfate, what do you think? Ammonium is one metal cation that is always soluble. So it's a soluble. Strontium chlorate, uh, you look at strontium, um, strontium chlorate, it is here, see. Strontium is, it's a, again, chlorate and also strontium. Strontium usually always soluble cation. So that is the about the solubility rules. Okay, after solubility rules, we learn about types of reactions. The types of reactions we are learning is first one, precipitation reaction. So what is this precipitation reaction? Here I'm showing you this is potassium iodide, which is soluble, right? Because it has potassium, group 1 soluble compound. Lead nitrate, again soluble. That's what we are mixing. Two clear solutions. When you mix two soluble solutions, you see the yellow color precipitate is forming. When you mix two solutions, when you and then you as a product, you get a solid or precipitate. We call that as a precipitation reaction. You see here potassium iodide, lead nitrate mix, you get potassium nitrate and lead iodide, which is a solid. When you get a solid, how do you know whether you get a solid or not? By knowledge from the solubility rules. Because you know, potassium nitrate is not a solid. Potassium is soluble cation, nitrate is soluble anion, so it's not a solid. But lead iodide is a solid. So this is the precipitation reactions. And then uh, this shows you this showing you how do you predict when you mix two solutions whether it's a precipitation reaction or not. If you want to see a precipitation reaction, for sure you look at the solubility rules. You see magnesium nitrate soluble because you have soluble anion. What is the soluble anion? Nitrate. Sodium hydroxide also soluble because of sodium, group 1 cation. So both solutions. And when you mix, you get, how do you predict the products when you mix? You see anions and cations switch, right? Magnesium goes with hydroxide. That's what I write. Magnesium hydroxide, sodium nitrate. And then magnesium hydroxide is a solid. So that is the precipitation reaction. We call the precipitation reaction, another name for this precipitation reaction, metathesis or exchange reaction. That's the same thing. So this is the how do you write fully balanced metathesis reaction. Um, and then whenever you have any metathesis or exchange reaction, we call double displacement reaction, there are three main ways you can represent this equation, this reaction. Three types you can write this reaction is molecular equation, complete ionic equation, net ionic equation. This is important. In the exam or in the homework, I'm asking, write the molecular equation for this particular reaction. Write complete ionic equation for this particular reaction. So you need to know clear difference between what is molecular equation, what is complete ionic and net ionic equations. Let's see what is this molecular equation, complete ionic and net ionic equations. Molecular equation has it lists also, this is the molecular equation. You write it as a molecular format. Lead nitrate, this is what you have seen so far, because you know lead nitrate, potassium chloride, you exchange lead goes with chloride, and then because lead is stoichiometry 2, 2 goes under, remember we put the charges switching, and then potassium nitrate, and then you look at the solubility rules. Okay, the potassium nitrate is soluble because you have two soluble ions, but lead chloride is a solid, and the lead nitrate is aqueous, potassium chloride is aqueous. So this, and then you balance. So this is the molecular equation. How do you write complete ionic equation? Complete ionic equation is if it is not a solid, not a liquid or gas, you separate them into ions. So what is that? What is if it is not a solid, not a liquid, not a gas? This is not a solid, aqueous, right? Not a liquid, not a gas. Same here. What about this one? This is a solid. So when you break all the components into ions, except solid, liquid, gas. So you break all this compound into its ions, this compound into its ions, this one, but you leave this compound as such. You don't break it into ions. So let's see what I'm talking about. Okay, so you break lead nitrate, you know you have Pb2 plus, NO3 minus, potassium iodide, and then lead iodide. You don't break it, you leave it as such. So this is why you call complete ionic equation. And then you go to net ionic. Net ionic, if you see the ion in the both side, you cancel out. Nitrate, nitrate cancel because it's in the both sides. Potassium, potassium cancel out. And then you have lead and iodide gives lead iodide. So this is how you write net ionic equation. Thank you.